Hello everyone, my name's Louis and I graduated year 12 in 2024 with an ATAR of 99.55 and I got 99% or 99 out of 100 in mathematical methods in year 12, getting 49 out of 50 in the methods external. And so I just wanted to do a quick overview of last year's or my paper's multiple choice for paper 1 tech free, just to help those out in the future. And I'll be posting this on my YouTube channel so anyone in the future can have a look and walk through these with me, and hopefully this helps in some way. So question 1, determine the integral of x to the power 4 dx. So we know with the integrals of just simple power functions like these, all we have to do is just add 1 to the power and divide that by what we have summed, right? And then we need to always remember our plus c. So that's going to equal to x to the power of 5 over 5 plus c. Or in other words, if we just take this out to here, then we can get 1 over 5 x to the power of 5 plus c, which clearly matches D, which is our answer. So good quick one. And question 2, determine the dy dx for the function y equals e to the sine x. We can instantly know that we have two different types of sort of functions here, so we can use the chain rule where we let u equals something significant. So in this case that would be the sine x, because when we know that if we let u equals sine x, then we basically convert this right here into e to the u, which is much more simplified if we were to derive this function right here. So I'll just rewrite y equals e to the u, and then basically what we do from here is we just derive both u and y in terms of x and u respectively. So du dx equals, in the formula sheet you will know that sine x, deriving that will just be cos x, and dy over du, differentiating that will also just, in your formula sheet you know that simply just the same thing, eu to the power of u. Yeah, and from that we know that the derivative of the original equation, so this is deriving this whole thing right here, is just going to be the multiplication of these. So we know that that is just going to be in the formula sheet is going to be they want the trigonometric one first, so cos x eu, and we can see, right, so just always remember, because the answer options won't usually have u, so we need to remember what u was. So u was originally it's just a bar arrow, u was originally sine x, so we just replaced that here with that. So we have cos x times e to the power of sine x, and we can clearly see that is just a. Moving on, a sample of size n can be used to obtain a sample proportion p hat. An approximate margin of error for the population proportion can be obtained using the formula as given. If the level of confidence is increased from 95% to 99%, then, well, in terms of level of confidence, that really relates to our z value. So I think from memory, z for was 1.64 and then 1.95 and 2.64 or something like that. You might have to check with that. I'm a bit rusty with these Z values, but they're usually for I think 68%, 95%, 99%, or something similar like that. I think no, this was 90%. But really just take this with a grain of salt. Essentially what I'm trying to say is that if we increase any level of confidence, then that means our Z value is always going to increase. Okay, no matter what the exact numbers are. I'm a bit rusty here, didn't check these, sorry, but essentially all we need to know is the relationship between things in these sort of questions. So if we increase a level of confidence, so as level of confidence increases, then Z value will also increase. So we can immediately cross out A and C because it's saying that the associated Z value would decrease. So it's not either of those options. So we're left with B or D. Now, if we look at this equation right here, we can see that like if we just focus on the two variables that we're really, I guess, concerned about, those letters are E and Z. And then we can see here that if I just underline those two variables, we can see here that we can predict what would happen if we increase Z, right? So say we increase Z to a very high number. So in that case, in terms of my numbers, maybe from 1.95 to 2.64. If everything else remains the same, what will happen to E if we increase Z? So just pretend this was a value, say like, I don't know, like 2 or something. It can be anything. And Z was maybe like 2 as well, right? If we increase Z to like a higher number, say like 4, then this entire expression, in other words E, will definitely increase. It's just kind of like common sense as well. So we can cross out D then, and the answer is really B, because we can say mathematically that E is proportional to Z. Okay, and what I mean by that is that anything that happens to E, whether that's an increase of E, will always increase Z, and vice versa as well. So if Z increases, E increases. That's what we call it direct or like proportionality. They are proportional to each other. And you can tell because they're on the same sort of line, like it makes sense. Another type of proportionality is inverse. And this only happens when we have one of the variables in the denominator of a fraction. But in this case, we don't have that because we just have E and Z. Like if we just remove this, we can clearly say that if Z increases in the value, E will increase as well. So I hope that also makes sense. But let me know in the comments at all for any of these questions that I do, if you have any questions or confusion that that has occurred, and I'll be more than happy to help out. Right, question 4, simplify y equals 2 ln ex. Okay, so this requires us to understand our log laws. Now we know that ln of e to the power of x is just basically log e of that, so we just gotta remember that ln is log e. That's really the easiest way to go around this, and we can just know then that our log laws say that if we have a power in what we are, I guess, logging logarithmically, which is, I'm referring to this part right here, if there's a power like x, we can just take that to the front, all right? And it just changes it keeps the expression equivalent. So we haven't changed anything. These two are still equal. Right? These two in green are still equal, right? Just by the log rule where we take the power down to the front. And then basically if we think about what this expression means in blue that I've underlined, this part right here, that's essentially just 1, because anything log to the base of something, if that's the same as the base, it's just going to equal 1, because if we were to like think about it in exponent form, it's just basically e to the something equals e. Well, that's just something. That something is just 1, right? So it's just essentially x times 1, which is just x. But notice how we need to have a 2 in front as well, so we just put that there, 2x. So that's question 4's A. Right, question 5, determine the integral of a to b for 2 cos x dx, where a equals pi over 3 and b equals pi over 2. Okay, so in this case, we just basically use our formula sheet and other things to help us as well. So what I like to do is, instead of going straight to substituting these a and b values, I just integrate, pretend that it was a indefinite integral without the a and b. So it sort of doesn't complicate this question even further, and I can just separate it into smaller steps that are more manageable and less prone to mistakes, if that makes sense. So the integral of 2 cos x dx is, in our formula sheet, I just basically turn this into sine, and since there's no like b value in here, it's just 1, then it's pretty easy for me. So I can just say that is equal to 2 sine x. All right. And then what I like to do here is I like to now add my brackets in and then put my a and b values here, my boundaries of the integral. So remember that the b value, or the higher value, is like always at the top, and then the a value, or the bottom value, lower value, is always in the bottom. Okay, and so basically it's just substitution from here. So 2 sine pi over 2, which is our b value, minus, so what I like to do is I like to bracket these things. Each of my b and a values, I like to bracket them just to make sure that I'm really minusing b and a, because sometimes it can get a bit tricky with the negatives and signage and stuff like that. So to really separate them and show that I'm doing each one separately, I like to square bracket my b's and a's, substitutions. So 2 sine and then just pi over 3. Okay, so sine pi over 2 from memory is just 1, so 2 times 1, and then I can just bracket these like that because I've got rid of the like brackets here, round brackets, minus 2 sine pi over 3, that was from memory, I think that's pi on 3 over 2, and that will be 2 minus pi on 3 because I'm just canceling these out, and so the answer there is C. Yeah, so I guess this really just requires you to be very, very familiar with your sine and cos, like trigonometric, those like standard triangle, like pi ratios for sine and stuff like that. And I guess knowing your unit circle as well is very important in methods. So, knowing that pi on 3 is like, if pi is 180 degrees and you divide that by 3, that's 60. So it's about more than halfway diagonally from these two. So you'll have a dot like there, and then you can notice that, oh well, I'm much higher on the y-axis and sine is y and cos is x. So I know that it's going to be root 3 on 2 for sine, and then cos would be a half. That's sort of just how I like to know it, because if you're higher on the y-axis, then you know that it's going to be this one rather than this one by, like, I guess, familiarity, because you know that square root of 3 is going to be higher or greater than 1. So that's how I like to think of it. Question 6, differentiate y equals ln x cos x with respect to x. Okay, so immediately you should be thinking product rule. All right, so very easy, just make u equals to one of the products, so ln of x, and then v equals one of the products of the factors, sorry, it's a technical term, du over dx equals, in my formula sheet, I know that's just going to be 1 over x, and dv dx is going to be negative sine x for the derivative of cos x. And then from this, I can use my product year formula, where I'm just basically just cross multiplying these and adding them together. So u dv dx plus v du dx. So as I said, I'm just cross multiplying these two here and adding them. Okay, so I have ln x times negative sine x plus 1 over x times cos x. And then here I can just go negative. I like to put my negatives out in the front so I can make sure I got my negative signs correct, because that's a very easy way to lose marks. And I just like to put this on the numerator, cos x over x, and I like to see. Now, sometimes it's not going to look exactly the same, but I know that if I have still my minus ln x sine x, I can immediately look towards this one, and I can just think about how this plus cos x over x can just be moved here, and so that's what it is. So here, so the answer is D. Alright, this one probably was the hardest question on the multiple choice tech-free paper for me personally, because it was a bit of a unfamiliar situation. So 20 families are selected to participate in a lifestyle study related to family size. The number of children in these families is uniformly distributed as shown. A random sample of 5 families is chosen from this group without replacement. A possible mean number of children in the sample is... So you kind of have to think for a bit. So what mean? Well, what is mean? It's basically just the average, okay? And what is technically the average? It's just the, I guess, like, total sum of your x, like, you know, in your set. So you have like 5 numbers, because you've chosen 5 families essentially, and there's 20 families in this group, over the number of families you chose, right? And so what is the number of families you chose? Well, let's see. N equals 5 families, right? Okay, and so let's just substitute n for now. So we have average equals sum of all the numbers over 5, right? And then from here, just think about how the sum of all the numbers has to be coming from the frequency on the y-axis, okay? So let's try and think about process of elimination here. So can we choose 5 families, as in like sort of like 5 of these families, you know, and is it possible to get a mean value where we add the total of these, you know, sort of any 5 of these, whatever combination we make in terms of the number of children, is it possible to add those and get an average of 0? Well, first of all, that's impossible, because if the average was 0, for example, so we just let the average equal 0, then that means we would get a sum of the number of children, which is x here, equal to 0. But that's impossible, because every single one of these families has at least one child. Okay, so we can immediately cross that out. Right, so I believe when I did this question during the exam, when I was a bit stumped from it, I just used process of elimination here based on common sense. Okay, so we found what the lowest possible option was. What about the highest possible option? Well, the highest possible option here that they recommend is 5, but is that really possible? Well, let's try. Let's imagine we find the most possible combinations of 5 families that give the most number of children. So we have 4 families with 5 children. Okay, so how many children will there be in total, which is the x value? It's just 4 times 5, right? It's 20. But we only have a maximum of 4 in the frequency of 5 children in a family. So in this case, we have to think, okay, what's the next highest number of children we have? So we can pick one family to fill in for the random sample of 5 families that we need. So one family can have 4 children, right? And so we just add that to the sum total of this x. 20 plus 4 is going to be 24. And then from that, we know the average is going to be just 24 divided by 5, which is the number, the sample size, you know, the n value. And that's going to be, you know, if you're not really confident with your division, that's okay. You can do short division like this. So 420 minus 4 on 0, 4.8, you know. Alternatively, another trick I like to do with dividing by 5 is I basically just times by 2, 48, and then divide by 10. So I move this decimal point back to the left side, so it becomes 4.8. Yeah, that's how I usually do 24 divided by 5. Just times by 2 and divide by 10, or just move the decimal point to the left. So 4.8. Now, this mean is not 5, but we know that this is the highest possible mean we can get, so it's definitely not going to be 5. Okay, now we're just left with B and C. So 2, a mean of 2 or 1. All right. So it's sort of similar in a way if you think about it in big picture, what we did with 5. So it's kind of similar to 1, because 5 was the highest possible number of families. 1 is the lowest possible number of families, not in this like subset of options, but within the graph. And so it kind of makes sense that 1 has to also be eliminated, because imagine we choose 4 families with 1 child, so that's just 4 times 1, And then the only possible lowest one we can get is a one family with 2 children. And that will give just 2. So we just plus that for the sum of x, which is just 6. Divide that by 5, again times by 2. So 6 times 2 is 12, and then divide by 10 is 1.2. Right, and so again, this mean value that we got here as the lowest possible mean is not equal to 1.0. All right, so the only option left is 2. Now I'm going to quickly improvise here and try and find a possible combination where we actually can get 2 as the mean number. So I'm thinking maybe 2 families with 1. So I'm going to draw this in green actually to show that this is a possible combination. So 2 families with 1 child, 1 family with 2 children, or 2 families with 3 children. I'm just improvising here and just checking if this will, so this was 2 times 1, which is 2, 1 times 2 is 2, and then 2 times 3 equals 6. I really hope this works. So the total x is going to be 2 plus 2 plus 6, number of children, which is 10. Divide that by the n value, it's just going to be 10 over 5 equals 2. And so yeah, about 2.0 to be exact is, yeah, basically b. So b 2.0 is a possible mean number of children in the sample. Okay, and continuing on to question 8, the graph of f function of x is shown right here, and we want to know the graph of the second derivative f dash dash of x. So we need to understand what the second derivative means. It basically relates to the concavity of the original function fx. So when we talk about concavity, we mainly have like 3 different main points. So we have a concave down, which if you think of like a sad face, you can remember that's concave down, and concave up is like a happy face. So concave up. And then we have a point of inflection, such as this point right here, where it is the point where it changes, the concavity basically changes sign. So we might have a graph that was concave up, and then up to this point the concavity is 0 because it changes to a negative concavity going concave down at this past this point in red right here. So let's have a look at this graph of fx. So we know that we can trace out this graph and think about its concavity as we go along the x-axis here, so from left to right. So we know that it is concave down. We're making a sad face on the graph until around this point right here, until it becomes, as you can see, a clear defined, it's no longer a sad face anymore, it's a happy face, concave up essentially, right? So and that point is around, I'd approximate around x equals 1. Okay, so in other words, the concavity, or f dash dash x, which is, when we're talking about the second derivative, it relates to concavity, which is the rate of change of the fx, or in other words, the rate of the gradient changing. That's what concavity refers to. We know that the concavity of f dash dash, specifically at x equals 1, is equal to 0. So we need to find a graph where concavity or essentially like the graph has a value of 0 on the y-axis when x equals 1. So let's see. So we can see that we can immediately cross out a and b, because at x equals 1, those are not the graphs. Sorry, those are not points where x equals 0 on that graph. Okay, because in order for x to be y to equal 0 at x equals 1, it will need to have the graph will need to cross this point here. And then from that we can think about whether the concavity value, or the f double dash x, the y values for that are less than 0 or greater than 0 at specific intervals of our x values. So we know that from this point onwards, from x is less than 1, we know that the concavity is a concave down, so that means our concavity is going to be less than 0. Okay, and so if our concavity is less than 0, then that means that we are wanting a graph that shows values of negative y values that are negative where x is less than 0. So I'm leaning towards C. Question 9. At a certain location, the temperature degrees Celsius can be modeled by the function t equals 5 sine pi over 12 x plus 23, where x is the number of hours after sunrise. Determine the rate of change of temperature degrees Celsius per hour when x equals 4. So immediately we can highlight that we need to determine the rate of change of temperature, which is in a completely different unit to what we are given in terms of t. So we need to derive or differentiate this formula right here. Okay, so we know that dt over dx is going to be, for sine, when we differentiate, we just take the b value, pi over 12, out of the equation, so 5 pi over 12, and then change the sign to cos, and it's still going to be the same sort of sign, so we're not changing it to negative or anything like that. And then this plus 23 will just turn into 0 there. Okay, and then when x equals 4, so when dt dx, when x equals 4, we just simply plug in that value for x, so pi over 12 times 4, and then we just continue with the math. So we know that cos pi on 3, back to our unit square, which we had quite in question 5, we know that if we have a cos of pi over 3, which is 60 degrees, which is greater than 45 degrees, then I know that it's going to be half, because cos is my x value, and the higher I go in the unit circle, the less I am at the x or the cos value. Just a reminder there. So in other words, this would be 1/2 comma root 3 on 2 at 60 degrees, or pi over 3. So once I know that, then I can just simply multiply through, and I have a rate of 5 pi over 24, which is our answer, B. Okay. Given that log 10 of 6 equals 0.778, determine the value of log 10 600. So this is quite an interesting question, but basically it just requires us to apply log laws. So we can find a relationship between log 10 log base 10 of 6 and log base 10 of 600. So we know our log rules, if I just write them in red here, that any log to the same base, and I'm adding two logs of the same base with different of values here in brackets, then I can simply multiply them with this having the same base. Right, so if I'm logging with the same base, two logs with the same base, and I'm adding them, then I just basically multiply what's I've underlined in blue, right? So A times C. Okay, so we can apply that like here as well. So we can see that 6 and 600 really stands out in this question. And so given that it's a tech-free multiple choice, they're never gonna really trick you that hard in these sort of questions. You really have to find the fastest way to go about these. So I would instantly have to know that 6 times 100 is 600, and so I know that I can just manipulate some log laws to get to a easy beneficial answer that I want, right? So I know that this value here, I've highlighted in purple, is what is given in the question. So I have to write that down. And then I know that log base 10 of 100 is just 2, because 10 squared equals 100. And that's how the index notation for this log right here, essentially. And we're just trying to find that power value, which is 2. And we just add that together quite simply, and that gives us an easy answer of C. Alright, so that is the multiple choice question for 2024, my paper 1 Tech Free. If you have any questions or concerns, please let me know again and in the comment section down below, and I'm happy to answer and go through any questions again with you. Thank you for watching.